welcome back to Mama Physics. In this video, we are going to, it's a continuation of uncertainty propagation, and specifically, we are going to look at how to deal with uncertainties when you multiply or divide numbers with uncertainties. Okay, so just to keep mind of a few things, I will require you to know what absolute uncertainty is, what a relative uncertainty is. I will use the word fractional uncertainty, definitely I will use in this video. And also the numbers that I will use are on the top of this page here, which A, B, and C are going to have known values, okay? So let's get started. Okay, so for multiplying and dividing numbers, doesn't matter which, you will need to add, okay, but this time you are adding their relative uncertainties, okay, and to be, I guess the more functional term to use here would be their fractional uncertainties, okay. Their fractional uncertainty is essentially the relative uncertainty, but in the fraction form, okay, to get the total. So then after you add the fractional uncertainty, you're going to get a total fractional uncertainty for the product of your answer, whatever that is, okay? And if you want to take a look at your data table, the data table in your IB data booklet, it looks like, not that, it looks like this. So notice here, if y is equal to, you take some numbers, you multiply them, divide them, then you notice here that you will get a fractional uncertainty in the end. Notice that's delta y over y, so that's the fractional uncertainty of your total. This is equal to the fractional uncertainty of A, fractional uncertainty of B, plus the fractional uncertainty of C, all added together. Notice in the end, you get a fractional uncertainty. You don't get absolute uncertainty, you get a fractional uncertainty. So that means if you want to find the absolute uncertainty of your y, which is your total, you must multiply this fractional uncertainty by your calculated y answer to get the absolute uncertainty. Okay, so that's just converting from your fractional uncertainty to absolute uncertainty. You need to do the conversion, otherwise you end up with a fractional uncertainty, which you may not want. Okay, so I'm just gonna write this down here, what you got in the data booklet, so you have it in your notes. Now, of course, let's do an example so that you know exactly what this means. So here we have an example 4, which I will do, and maybe I'll give you a chance to do example 5. Oh, hey, look, I put the numbers on the top of my second page, so I'm just going to sneak peek it down here so you can see them. A, B, and C. So whenever you're stuck, you don't know what to do, the first thing is to actually do the calculations to see what you get. So I will do A times B times C right now. Putting that into my calculator, I get 1.08044, so no rounding yet. So next up, I'm going to calculate the uncertainty for the total, which here I'm going to use as y is our total. Let's say y is our total. So then before we get to the absolute uncertainty of y, we need to start off with getting the fractional uncertainty of y, because we're adding fractional uncertainties. We only get fractional uncertainty anyways. So here the fractional uncertainty of y is the fractional uncertainty of A plus the fractional uncertainty of B plus the fractional uncertainty of C. So what that looks like is, if we take a look at the values A, B, and C, so A here I have 0.03 over 7.48. I have 0.2 over 1.3 meters for B, and 1 meter over 9 meters for the fractional uncertainty of C. So I'm going to punch this in my calculator to get the fractional uncertainty of y, which is my total answer. And I get here 0.2689, so 268. Okay, and notice there is no units for this number because it's a fractional uncertainty. So technically speaking, these units at the top and the bottom cancel. So I'm adding unitless numbers. to give me a total of a unitless number anyways, okay? So keeping all those digits saved, I am not done yet. I have a fractional uncertainty that I need to convert to an absolute uncertainty, and we know, and hopefully we've learned this already, to get an absolute uncertainty, you need to multiply your fractional uncertainty by the actual number itself to give you the absolute uncertainty. So what that looks like is I need to take this 0.2689, whatever that is, it's a fractional uncertainty in the decimal form. I need to multiply this by my y value. So my y value is, I calculated that first, 1.0804 ... Notice I have to keep all my significant digits there in order to do that. And luckily I saved that on my calculator, so I can multiply that right now. I get 0.2906. And now I can actually attach a unit to this because I am now multiplying a percentage of an actual number that has units of meters. So this is my absolute uncertainty for y, which now I can use and try to round this off. From the look of things, 0.29 is definitely going to be greater than 2% of 1.08, so I'm going to round this to one significant figure. So that's delta y there. Rounding to one significant figure, I get 0.9 rounds of 2 up to a 3 meters, and I'm going to put the plus minus here. And the 1.08, I need to round this up to the 10th place as well. So this 8 is going to round my 0 up to a 1.1 meters. Okay, so there is my answer. Notice that there was an extra step to convert the fractional uncertainty to the absolute uncertainty. Okay, so the next one, example 5, will be good for you to do. So, good time to pause the video. I'm just going to show these the ABCs down here so you can see that. Okay, good time to pause the video. Now I'm going to do the solutions on Fast Play.
Here we have to first calculate what our total is, and this is taking A divided by B, then divided by C. That's going to give us 0.63 meters to the -1 for our units. And now we're going to add all the fractional uncertainties of A, B, and C to get the fractional uncertainty of Y. Then we can take the fractional uncertainty of y to multiply by the actual value of y, which is 0.6393. And since this is greater than 2% relative uncertainty, we round it to one significant figure. And then same thing with our answer, we're going to round it to the same place value.
Okay, and this is our final answer for example 5. So double checking your units, meters divided by meters, that's meters to the -1. And as well as the rounding, making sure you round to one significant figure for the uncertainty, and the number here, which is 0.6393, is a small number, which then also needs to round to the 10th place. Okay, so there we are, and that's it for multiplying, dividing two numbers with uncertainties. I thank you for watching. Hopefully you can use this in your practice, and Fat Mama Physics signing out for now.